Good evening everyone, am I audible? Good evening all. Deepa, good evening. Sindhuri, Surong, good evening. Shall we start the class? Mahesh Murugan, good evening. Santosh, good evening. Shall we start the session, guys? So today's topic is ESP8266 NodeMCU web server with slider. Actually, we are going to control LED brightness using pulse width modulation, and we are going to control that pulse width modulation using the web server slider. So today I will show you how to build an ESP8266 NodeMCU web server with a slider to control LED brightness. So you will learn how to add a slider to your web server projects, get its value and save it in a variable that the ESP8266 can use. So we will use that value to control the duty cycle of a pulse width modulation signal and change the brightness of an LED. So for example, instead of an LED you can also use a servo motor. So I think we have already saw a session for pulse width moderation, right? So now you will get to know how to use that pulse width modulation, how to give a delay and how to give duty cycle, frequency and everything and all. So instead of LED you can also try servo motor also. So additionally you can also modify the code in this tutorial to add a slider to your projects to set a threshold value or any other value that you need to use in your code. So you can customize it at your own. So first let's see an overview. So this is how it will be. So in your web server your pages look like this and you will get an output like this from 0% to 100%. So the ESP8266 hosts a web server that displays the web page with the slider. So this is the slider at a 10-bit resolution, right? So we will get a value of 1023. So this is the heading ESP web server. So when you move this slider you make an HTTP request to the ESP8266 with a new slider value. So the HTTP request comes in the following format, this format. So get/slider value which is equal to the slider value, whatever the value you are sliding through. So there is a number between 0 to 1023. You can modify your slider to include any other range also. So from the HTTP request, the ESP8266 gets the current value of the slider. So this microcontroller adjusts the pulse width modulation duty cycle accordingly to the slider value. So this can be useful to control the brightness of an LED or a servo motor and setting up a threshold value or other applications, right? So for that, before getting into the topic, we need to install two libraries. These two libraries. We need to install these two libraries, then only we can create the web server. So these two libraries, one is ESP async web server and ESP async TCP. So these libraries actually are not available to install through your Arduino library manager. So you need to copy the library files to the Arduino installation libraries folder. Alternatively, in your Arduino IDE, you can go for like sketch include library and you can download the zip library and select the library that you have downloaded. So I will provide you the link, okay? So you can download using that link. Wait, I will provide you the library link. provided in the chat box. Make use of it. So using that you can download your library. So now let's get into the code. So first we need to include the necessary libraries for the ESP8266 Wi-Fi module, the asynchronous TCP library and the asynchronous web server library also. So this first library, we have included this library so many times, right? So this library provides the functionality to connect the ESP8266 module to a Wi-Fi network. Then take these two libraries. One is ESP async TCP. This library is used for asynchronous TCP communication. And this library allows you to create an asynchronous web server on the ESP8266. Then what we have to do is that we have to initialize the network credentials. So these lines define the SSID, which is your Wi-Fi SSID network name, and password of the Wi-Fi network that the ESP8266 will connect to, right? So you should replace these values with the actual SSID and password of your own Wi-Fi network. So then coming to this constant integer output, which is D4. So this line declares a constant integer variable named output and assigns it to the value D4. So the D4 is a predefined constant in the ESP8266 library that represent a specific GPI open, right? So in this case, the output variable is used to store the pin number that will be used for output. And then this line, string slider value, which is equal to 0. So this line declares a string variable named slider value and initializes it with the value of 0. This variable will be used to store the value received from a slider in the web interface. So it starts with the initial value of 0. And this line, constant character PA or AM input, which is equal to value. So this line defines a constant character array, which is a string that assigns it the value of value. It is used as a parameter name to retrieve the value from a post request. So in the web interface, the value from a slider will be sent as a parameter with the name of value. And this line, asynchronous web server, which is 80. So this line creates an instance of the asynchronous web server class name server and assigns it to the default HTTP port, which is 80. And this class provides the functionality to handle HTTP request and serve web pages. So by passing the port number 80 to the constructor, the server will listen on this port for incoming HTTP requests. So this is all about initialization. And coming to this here, the first line. So this line declares a constant character array. Name is index_html. So and it initializes it with the raw string literal. So the program attribute indicates that the array will be stored in the program memory of the microcontroller. So this is commonly used on embedded systems with limited RAM to save memory space. Now this. Then inside all these lines, what are the definitions of all these lines? So I will tell. So this line contains the HTML and CSS code for the web page that will be served by the ESP8266. So it defined the structure, it defined the style, it defined the layout of the page. The page title is set to ESP web server, right? So and the content is centered with the specific font size and style. So it also includes styling for a slider input element. So this line defines the heading, slider value display, the slider input element, everything and all. And this the percentage slider value. So this placeholder will be replaced with the actual slider value dynamically. So the slider has an ID of PWM slider, which is pulse modulation slider, and is said to have a minimum value of 0, maximum value of 1023 and a step of 1. So this JavaScript code defines a function name update slider pulse width modulation. So that is called when the slider value changes. So it retrieves the current value of the slider, updates the text display and logs the value to the console and sends an asynchronous get request to the server endpoint, which is that /slider, this line. So this line ends with the HTML code and closes the raw string literal. So the closing parenthesis, semicolon and the quotation mark, everything. So complete the initialization of the index underscore HTML constant character array. So overall, this code defines a raw string literal that contains an HTML web page with a heading, slider element and JavaScript for updating the slider value and sending it to the server. So this web page will be served by the ESP8266 web server to provide a user interface for controlling the slider. So now this line, string processor, inside I gave constant string, address and variable. So this line defines a function named processor that takes a constant reference to a string object as a parameter and returns a string object. So the purpose of this function is to process variables which is used in the web page template and provide appropriate value. So coming to inside this if condition. So this line checks if the input variable is equal to the string or not, string slider value. So if it matches, the function returns the value of slider value variable. This is used to replace that particular percentage slider value placeholder in the web page template with the actual slider value. And this return string. So if the input variable does not match any known variable, the function returns an empty string object. So this ensures that if any other variable is used in the web page template, it will be replaced with an empty string, effectively removing it from the final rendered page. So overall this code defines the function processor that is used to process variable in the web page template. It checks if the variable is slider value and returns the value of the slider value variable. Otherwise, it returns an empty string. And then coming to void setup, first is baud rate. So this line initializes the serial communication with a baud rate of 11.500. So it enables the board to communicate with the computer or other devices via USB cable. So serial communication is often used for what? Debugging and logging purpose, right? And then coming to this analog, right? Inside I gave output slider value dot to int. So this line uses the analog write function to set the output pin, which is specified by the output variable. So to the value of the slider value variable. The toInt function is used to convert the slider value string to a integer. Int means integer before setting the analog output. And then as usual Wi-Fi, begin of SSID and password. So this line connect the ESP8266 module to the Wi-Fi network. So it uses the Wi-Fi.begin function to initiate the Wi-Fi connection using the provided SSID, which is your network name and password. And then as usual, while loop for Wi-Fi checking, this loop. And this while loop continuously check the Wi-Fi status using Wi-Fi.status function. So and the program waits for a successful connection before proceeding, right? And then it will print the local IP address on your serial monitor. So this line prints the local IP address of the ESP8266 module to the serial monitor. So it allows you to know the IP address assigned to that particular microcontroller, which is ESP8266 on the local network, which is useful for accessing the web server running on the ESP8266. So using that only we can go and search for the web server, right? And then coming to this lines. So this line defines the handler for the root URL of the web server. So when a client requests the root URL, the specified function is executed. So it uses request send p to send the index_html web page as a response with the content type of text/HTML. So the processor function is also passed as a parameter, allowing variable substitution in the web page. And coming to this line, so this line defines the handler for the slider URL of the web server. So when the client requests this URL, the specified function is executed. So this handler is responsible for handling requests related to the slider value. We're coming inside this string input message. So this line declares a string variable named input message, which will be used to store the value of the input message from the client. And coming to this, if request this condition, so this line check if the request made to the slider URL has a parameter with name value. The hash parameter function is used to determine if the request contains the specified parameter or not. And this input message, which is equal to request get parameter input and value thing. So if the request has a value parameter, if it has the particular parameter, this line retrieves its value using the get parameter function and assign it to the input message variable, and then it will store that in slider value. So this line set the value of the slider value variable to the value of input message. So it updates the slider value with the new value received from the client. And this line uses the analog write function to set the output pin, which is specified by the output variable, to the new slider value. The toInt function is used to convert the slider value to an integer before setting the analog output. So else function. So if the request does not have the value parameter in the sense, this block of code is executed. So it set the input message variable to the string, which means no message sent. So this indicates that the client did not send a valid parameter. And then it will print that input message. So this line prints the value of the input message variable to the serial monitor. So it is useful for debugging and monitoring the received input message. And then it send like request send 200 explain OK. So this line sends a response to the client with the 200 OK. So that the status code and it explain content type. So the response body is set to OK. This indicates to the client that the request was successfully proceed. And at last server begin. So this client starts the web server and begins listening for incoming client requests. So once this line is executed, the web server is up and running, ready to handle incoming HTTP requests. So it enables the server to respond to client requests for the specified routes and perform the associated actions defined in the request handlers. So there is no need for giving anything inside the void loop, right? So for that I am leaving it blank. So this is all about our code. Is it clear everyone? Do you have any doubts regarding this code? Is it clear? Is it clear everyone? If it is clear in the sense, just drop S in the chat box please. Is it clear everyone? Do you guys have any doubt regarding this? If it's clear in the sense, just drop S in the chat box please. Are you guys are listening or not? Just drop S in the chat box. If you have any doubts in the sense, you can ask me. Selva Kumar, thank you for your response. What about the remaining members? Now let's move to the hardware part. So the connection is very simple. We just need to interface that LED resistor and jumper wires. So I place this. At the side I place the 2k ohm resistor. So the ground has to be connected with the one end of the resistor and the ground is here. And the other end of the LED has to be connected with, we have taken D4 pin, right? So D4. So now let's see. Before that, make sure that you have selected the board and port. Wait a minute. Yeah. So first, let us upload this. Let us wait for a few minutes. It is uploading. I have already uploaded the code I have uploaded another code into the microcontroller. That's why the LED is blinking. Our code is error free. It's uploading. Yeah, it has uploaded. So now after uploading, open the serial monitor and check we have selected the correct baud rate. Yes. So here press reset button. So here it should print the IP address on the serial monitor. So here it is our IP address. So what we have to do is that open your browser. So here you have to type that IP address. So ours is 192.168.2.129. There is some issues with IP address, I think. 192.168.2.129. Yeah, there is some issues with that IP address. So let me show you an output video of this. actually the output will be looking like this. So if you are adjusting your slider in the sense according to this value, your LED brightness will be adjusted. So here you will get your value also. In your serial monitor you can get your value also. So according to this slider, your brightness of your LED also adjusted. So this is your output. Is it clear, everyone? So is it clear, everyone? So this is all about today's session. Is it clear, or do you have any doubts regarding this? So it's already 18th day. What about your assignment? Have you all submitted your third assignment? So only 2 more classes are there, and 23 you will get your fourth assignment. And that's our last class. So up to this class, up to 18th day, you have any doubt in the sense, do you have any queries in the sense, you can ask me in the installation process or something. Do you found any difficulties in the sense, you can ask me. Is it clear, everyone? Do you want me to repeat any topic, or do you have any doubts? So that's only 2 days left. So before that, if you guys have any doubt in the sense, you can ask me. So if everything is clear in the sense, just drop S in the chat box, please. So this is all about today's session. Thank you all. Have a very nice day. Let's catch for tomorrow with next topic. Thank you all.